Yeah. It's only going to take up 15 minutes of your time. Okay, here we go. So everybody, it says solve the inequality. Now this is not a rational inequality. This is a quadratic inequality. But if you see, I really did not used to grasp the concept of what the teacher was saying when I was graphing rational inequalities. So I'm going to start out basic to help you hopefully see what you're doing and make sense of it, instead of just following the steps. So here we go. It's literally asking us, so what this says is, when is this function 2x squared plus 9x minus 5, when is that less than or equal to 0? Now we're going to answer in intervals of x. So we're going to say x values between here and here is when my function is below 0. Now, below 0 for y. When I say below 0, we're talking below 0 for y. So do you see how on this interval for x, from this x to this x is when our function is below 0. Yeah. So that would be our solutions. From this x value to this x value. All of those fall in our solution set. How would we find this value and this value? Any suggestions? It's a quadratic. Find the zeros by factoring. Here we go. You're right. What multiplies to be negative 10 and adds up to be 9, 1 times 10, negative 1. Long factor, so we would have 2x squared. I know you know how to long factor, so I'm just going to kind of go quick if you're not mad about that. So then we would pull out an x, a 2x, left is x plus 5. We would pull out a negative 5, left is x plus 5. We pull out a negative, I'm tricking you. Pulling out an x plus 5 and left is 2x minus 1. You're right. Okay. Right, now I'm just finding the zeros. So I'm just setting this equal to 0, find the zeros. So x equals negative 5 is where it touches down for x. And positive 1/2. So this is at negative 5, this is at positive 1/2. So my solutions are between negative 5 and 1/2. Now isn't that easy to see because I have a picture of the graph? Okay, so my answers are negative 5 to 1/2. Well, let's pretend like I was having you solve. So we technically solved by graphing. But what I want you to understand is if I gave you instead of a quadratic and a rational, do we love to graph rationals? Not really. Isn't that probably the hardest lesson of this whole unit, was graphing a rational? So we don't want to have to solve by graphing. Instead, we would rather solve by the method of like testing intervals for x. So everybody, let me show you how to solve this one a different way to help. Oh, yeah. By the way, sorry, let me say one more thing. Shouldn't we be putting brackets because of the including 0 sign? So at 0, when the function is equal to 0 is included, so we got to put negative 5 and 1/2. Okay, I didn't specify. Okay, anyways, so let me show you a different way to solving. Instead of solving by graphing, let's solve by testing intervals for x. So now we wanted to know when the function is less than or equal to 0. So we find the zeros and we test those values. So look, we test intervals. So we found negative 5, we found 1/2. Now I'm going to test an interval here below negative 5, a value below negative 5. And let's plug it back into the original here. So let's test a value less than negative 5, maybe negative 6. So what I would do is go plug it into the original. So that would be 2 times negative 6 squared plus 9 times negative 6 minus 5. Is that less than or equal to 0? Go, tell me what that is. So everybody help today. Type it in. You got 13? Okay. So when we tested negative 6, we got 13. Is 13 less than or equal to 0? No. So we know that this is not in our solution set, this interval. Does that make sense, everybody? Yes. Now let's test a value between negative 5 and 1/2. I don't know what's an easy value. 0. Let's plug in 0. So everybody look. 2 times 0 squared plus 9 times 0 minus 5. Is that less than or equal to 0? Is negative 5 less than or equal to 0? So yes, this gets to come in our solution set. Let's test a value above 1/2, maybe 1. Plug in 1. Go. Yep. So is 6 less than or equal to 0? No, know. So look, guys, this is how we're going to test our harder ones. So if you're not focusing, you're going to be confused. So we know this was yes, and because of the equal to, less than or equal to, these little guys are yeses, because those are the equal to part. All right, so now we can say our solution, since this is yes, is from here to here. So we would then be able to say from -5 up to a half, including -5, including a half. Wouldn't you rather solve by testing values when it comes to like solving a rational? Would you rather graph it or just solve by testing values? Solve by testing values. I don't want to graph a rational myself if I don't have to. So we'll just test values. Any questions on that? Okay, let's get to a harder one. Now, but a lot of people say, well, why are we testing the zeros? Because that's, think about it, if it's less than or equal to 0, we want to know when it's above 0 and below 0, so we got to find zeros. Does that make sense? Find the zero. Okay, so here's my first example of a rational inequality. Now, notice this one says less than or equal to 3. I would like to look at 0 because, once again, if this quadratic would have been less than or equal to 3, we wouldn't have been looking at the zeros. We would have had to go, oh, okay, now we're talking 1, 2, 3. So these would have been in my solutions. Does that make sense, everybody? But, so it's easier to look at zeros because it's easier to find the zeros. Does that make sense? So instead of saying, I want to look at this, I like to compare it and look at it when it's equal to 0. So let's manipulate this and make it equal to 0. So rewrite what you have. X over 4 minus x minus 3 is less than 0. Now, one thing I want to point out to you is it's a lot easier to picture the vertical asymptotes and holes and stuff if you don't have two different pieces here. So let's combine this into one rational by getting a least common denominator. Does that make sense, everybody? My goal here. So let's get a least common denominator. There's so many ways to do this. I don't really care how we do it. Should we just go ahead and go 4 minus x? I agree. So then we would have x over 4 minus x minus 3. Minus 12. Minus 3 times 4. So I am distributing this through. So we have minus 12. And then careful, right here, this times this. Wouldn't that be positive 3x? And that's all over 4 minus x. Now, because we have a common denominator, we can combine the numerator. Can't we? Okay. So we would have x plus 3x is, we wouldn't distribute the negative because didn't we already right here distribute the negative? Okay. So that would be 4x, right? Combining the tops. 4x minus 12 all over 4 minus x. I just combined this into one rational. Now think about it. So look at this. We have to know, we're trying to find intervals for x that makes this a true statement. So we're going to need to find values for sure that we know x is not, correct? Yeah. What is definitely not going to be in the answer set here? 4. So let's go ahead and draw in our number line. So that's going to be your first step, is find your discontinuities, because those are values your function could definitely not be. If you're writing yourself little notes. What the heck? I can't talk and write at the same time. Or I can't spell very good. Let's be straight on this. Okay, discontinuity. So first find your discontinuities. This one is x equals 4. So we definitely know that it is not going to be 4, but that's going to help us know where we should test, intervals for which we should test. We're going to add that to our number line. Then second, since we're looking when is this function below 0, we need to know where is it equal to 0, right? This is not where it's going to change from up and down. You get what I'm saying? So let's solve if this was equal to 0. Let's pretend this isn't an inequality. So we have 4x minus 12 over 4 minus x equals 0. Solve for x. So we'd multiply by 4 minus x to both sides. So won't these divide out? 4x minus 12. When is that equal to 0? 0 times that's 0. So solve for x. What do we get? X equals 3. So that is when our function is equal to 0. So the second thing you do is find the zeros. So that's also where we've got to test. So 3 is where I'm going to test as well. Does that kind of make sense? Okay. Now, once again, we could graph this and physically look with our eyeballs to see where's our function below 0. Does that make sense? For intervals for x, but that's a lot harder than just testing values. Okay, now we can test. So, my next question is, we said this one's definitely a no. That's not in our domain. Is 3 in our domain? Was it or equal to 0? It wasn't. It's not. Or equal to 0. This is where it is equal to 0, so I'm going to put a little no there as well. It's definitely not 3 because it's not or equal to 0. Okay, sweet. Here we go. Let's test a value less than 3. 0. Yeah. Yeah? Okay, let's test a value larger than 3. I don't know. 3.5. So it's got to be between 3 and 4. You good? And then let's test 5. Ready? Pick one and test it, and then tell me, oh, when I plugged in 0, I got this. Now you're going to plug it into the original, or not the original necessarily. What we're going to want to plug it into is when it was less than, like, yes, one of the originals, but the original we made set equal to 0. Does that make sense? You can plug it in anywhere. You can plug it back into the original if you want. You can plug it back into the original, and if it's a true statement, you're good. If not, no. Okay, sorry, what? 5 is negative 8. So we're looking at, we plugged in 5, and we got negative 8 is less than 0, which is true. So I'm going to go ahead and highlight this. This is part of my solution set. When you plugged in 3.5, what'd you get? You got 1? Are you all typing in something? Don't wait for other people to do it. This should be done, because they should have typed in 1. What? So is 4 less than 0? Okay, so we're not going to highlight that. That's not part of our solution set. When you plug in 0, you get... I got... negative 3. Is that less than 0? Yes. So I'm going to go ahead and highlight. So look, the highlighted region is our answer. So coming in hot from negative infinity up to 3. 3 is not included. Look, it says no. Union. Then it starts at 4. Look, no there. So parenthesis to infinity. Those are the values for x, which are in our solution set, yes. So good question. So it's definitely never going to be 4. Because that would be our vertical asymptote, right? Discontinuities are x values that our function will never be. So 4 cannot be included. Right, the bottom would be 0. Right. Well, we just had to test a value between this and this. So that's going to be an interval where things are happening. Where it's going above 0 and below 0 and stuff. Let's do another example. Write it down. Here we go. Okay, so we could go ahead and graph and shade and try to solve that way, but that's really the hardest way. Instead, it's easiest to kind of look at this when this function is above 0 and below 0. So let's go ahead and make it equal to 0. So there's a couple different ways we could do this. We could bring this over this way or this over this way. I'm just going to go ahead and subtract x plus 5 over x plus 2 from both sides of the equation. Because that would be 0 on this side. So now on this side, on the left side, I have x plus 1 minus x plus 5 over x plus 2. And that's greater than 0. Now once again, it's easier to see the values our function cannot be and the zeros if you're just dealing with one fraction. So let's go ahead and get a least common denominator here. So we're going to multiply by x plus 2. Make sure you use parentheses around two terms. That always helps. So now right here, I'm going to multiply that out. That's x squared plus 3x plus 2 over x plus 2. And then I'm going to distribute my negative through. So I'm going to have minus x minus 5 over x plus 2, and that's greater than 0. Now, once again, do not do that thing where then you refactor this and start dividing out things because you're going to end back right up here if you do that. Do you all understand? Yeah. I still saw people do that on the test. It was such a sad day. Oh, well, you couldn't distribute it to the top and bottom, or that'd be like if we had a positive, right? Top or bottom, we could distribute. Very good question, though. Okay, let's continue upward and onward. The whole point of getting a common denominator is so we can combine the numerator. So combine like terms. So we have x squared plus 2x minus 3 all over x plus 2, and we want to know when is that greater than 0. Now, the first thing you do for your number line is figure out your discontinuities, because those are values that are not in the domain for sure, are not in the solution set for sure. So x equals 2 is a discontinuity. Not true. X equals negative 2. That's a discontinuity. It's definitely not in our domain. So I'm going to add that to my number line, which we know is a big fat no. It's definitely not going to be in our solution set. Okay, so now once again, we could go ahead and factor the top if we wanted. So it would be x plus 1. Nope. X minus 1. Well, multiplies to be negative 3 for the video and adds up to be 2. 1 times 3, negative 1, right? Yeah. So the top factors to be x minus 1 and x plus 3 all over x plus 2. So once again, though, we know even if it did divide out, it's still a discontinuity, right? Even if they did divide out top and bottom, it's just a whole. But it's still a discontinuity. Okay, so now the second step is to say, okay, well, since we're looking at when is this function greater than 0, that's going to be solving for x. So your second step is to find the zeros. So we would go ahead and just pretend like this is equal to 0 and solve. Yeah, bless you. So we'd multiply both sides by x plus 2. So then 0 times x plus 2 is 0. So we would have x minus 1 times x plus 3 equals 0. Solve for x. X equals 1 and x equals negative 3. I don't know. That's what I'm trying to figure out. X equals 1 and x equals negative 3. Yeah, that's why. Negative 3 and 1. And I promise you, if you were to go back and graph this, you would see that our answers are going to come out correct. Okay, let's test values on each interval now. I don't know, test a value less than negative 3. Let's test negative 4. A value between negative 3 and negative 2. Let's test negative 2.5. A value between negative 2 and 1. I like that idea. And then let's test something larger than 1, test 2. Pick one, go. No, everybody pick something that you think no one else will pick. No, pick the easiest one. Because then I know what kind of student you are. Just kidding. I'm trying to guilt trip you into picking the hard ones. It's been proven right. Every single hour, this is the last one to get calculated. And it's like, hey, did anyone pick this? And there's crickets. And I'm like, I know. Good job. See? Okay. You got what? Is negative 3, let's look back at the original, greater than 0. Okay, let's continue. Tell me what's here, what's here, what's here. Anyone shout out one? Look at you. Negative 1.5 greater than 0. And now in this interval, what'd you get? 1 is greater than 0. Is anyone else helping me out besides him? Okay. He's just really fast? Okay, sounds good. Let's see which ones are true statements. Is negative 3 greater than 0? Nope. What about that? Is that greater than 0? No. Wait a minute. Something happened. That's okay. That's okay. So what'd you get here? That's okay. That's why it's a good point. You tell me. Did you get positive? Okay, I think it was positive. Okay, so now we would say yes on this interval. Am I right or am I right? And then isn't this one a yes too? Uh-oh, something happened on this one too. What was this one when you plugged in 0? Isn't it negative 1.5? It's okay, Kai. Okay, fine, you're right.
I will try.
Negative 1.5 is greater than 0. So, do you guys see why I picked the intervals? I highlighted the intervals I've highlighted now. So now we can answer it. Well, question for you, was the -3 and the 1, they're zeros, correct? Are zeros included in the domain of this one? Not equal 0. So these both get little no's and little no's. I like to write them. Okay, here we go. So we know that -3 up to -2 is a solution. No, no. So parenthesis, parenthesis. Does that make sense of why I'm saying that? Okay. Union, and then from 1, since that's a no, I put a parenthesis, 1 to infinity. And there's my answer. Okay, question for you. If that's making sense, we're good to go. If you want one more example off the test review, we can do one more.
Yeah.
Yes. No, union just means both are included in our answers. Okay, let's do it. Here we go. I think one more. Okay, let's go quick though. So the first thing, once again, it's really easier to compare when it's equal to 0. So I'm going to add 3 over x minus 7 to both sides. Now remember one thing to note, if you multiply or divide both sides of an inequality by a negative, you've got to change the inequality. But we haven't had to do that yet with getting it equal to 0, which is nice. Okay, common denominator. So then we would multiply this out. So we have 6x minus 42 over x plus 2 and x minus 7. Then we have plus 3x plus 6 over, so I distributed that through, all over x plus 2, x minus 7. Then you'd say, I have a common denominator, so now I can combine the numerator. So that would be 9x minus 36 all over x plus 2 and x minus 7. Now, once again, we need to figure out what intervals we should test here so we know what's definitely not in our domain. So the first thing you do is find your discontinuities. So x equals -2 and x equals 7 are discontinuities. So we're going to be testing 7. We're going to be testing -2. We definitely know, once again, that those are no's. I like to just add that in there. So when I'm putting in my answer, it's really easy for myself. And then we also, since it's less than or equal to 0, we need to find the zeros. So we would just say, okay, 9, factor out of 9, left is x minus 4. I did 5 last hour for some reason. When does that equal 0? So we'd multiply out by the denominator. So the denominator times 0 is 0. So we have 9 times x minus 4 equals 0. So divide by 9. Divide by 9. Add by 4.
And we get x equals 4.
X equals 4 is an equal 0. So 4 is also where we're going to test. As our second step, find the zeros. No, if you multiply 9 back in, you'll have 9x minus 36. So you'll add 36 divided by 9, right? You're doing good. You're fine. Okay, yeah, no, you're fine. Okay, here we go. So let's go ahead and test. Test -3. Test 0 maybe. Test, I don't know. 5, not a bad idea. Test, I don't know, 8. Okay, let's see which ones are yeses. Which ones are true statements. Now I could test it right here or back at the original. It doesn't quite matter. True statement. So just tell me if it's a yes or a no at this point. Maybe like, is this a true statement? Is this a true statement? Is this? Make sure you're right. I don't want any mistakes on this one. Once I highlight, it's a done deal. Just kidding. No, don't be sorry. No, you didn't. You're fine. Well, you're the only one that was participating. You're fine. I'm just trying to make you feel better. Quiet. You're saying this one's a yes?
Yeah.
Okay. Anyone else? 8's a no. Okay. No, pretty sure. Is it yes? So let's check. Is 15? Oh, you got 15.7? Okay, perfect. Are we all good? Do you want me to show you what I'm doing, or do you? Oh, you do. Okay. Do you guys understand that we're literally just plugging in the -3 right here? Yeah. Okay, plug it in. What did you get? Divided by this, right? Yeah. You can plug it in anywhere. You could go back to the original. I just like to plug it in where it was less than or equal to 0. I like to, but once again, you could have, if you plugged it into the original, you would just be comparing the two inequalities. And if it's a true statement, it's a yes. If it's a not true statement, it's a no. So like it, yeah. Okay. Did you guys take the liberty of typing it in? What'd you get? It is, that's right. -6.3. Is that less than or equal to 0? You guys haven't divided yet. Are you typing in this? No, we've been getting -6.3 all day. Make sure you're using parentheses. Yeah, no parentheses equals bad news. Then plug in 0. If you plug in 0, I can see right now, we get a positive number. Is a positive number greater than 0? No, so we put no. That makes sense. Okay, yeah, at least you would have still got it right. Do you? Hey, you guys, you got to tell me if you're not understanding what I'm saying. So I plugged in 0 and got some positive number. Is a positive number less than 0? No. So this is a no. That's why I didn't highlight it. Now when you plug in 5, you get a negative number. So that's why we're saying yes. Does that make sense? It's a true statement. A negative number is less than or equal to 0. That's a yes. When you plug in 8, you get a positive number. Is a positive number less than or equal to 0? No. Does that make sense, everybody? So now we can go ahead and answer it. From -infinity up to -2. -2 is a no, notice. Let's see. Or equal to, so 4 is a yes, and isn't 7 a no? Good point. So then union, the interval for 4 is yes, so we got to put a bracket for 4. Because it was or equal to 0, so that one's a yes, up to 7 parentheses. Because that was a discontinuity, which are definite no's. Now, if you're curious, I know I taught you how to graph it, and look to see that this is truly the interval for x for which this function is less than or equal to 0. Okay. That's the end of the lesson. So what I want you to do is finish the test review. As much as possible, that is. Get help, check your answers online, get a study group, do well on this test.